Okay, before we start our lesson, just make sure that you have your reader's journal in front of you. And I want to start by pointing out the standards that we use are Florida state standards. This is the LAFS at the front. It means Language Arts Florida Standards. 4th grade, Reading Informational Text, RI. And this is actually the standard number 4.10, okay? And this standard, which we kind of keep coming back to on and off, just depending on the lesson, this is a standard that we're going to work toward for the entire year. So we're not there yet, but this is where we want to be by the time we end our school year and are ready to move into 5th grade. And it says that by the end of the year, you should be able to read and comprehend informational text, history, social studies, science, and technical texts in the band for 4th and 5th grade. And that's basically, it goes by complexity, because as you go through each year, the text gets more complex, okay? And the scaffolding that is needed until you can do it independently at the end of the year. Okay, today's workshop, and make sure to look down quick and see if you remember to put the date. This is the title. Don't skip the hard stuff. Now, when we're reading, and we've discussed this at the very beginning of the unit, when we talked about the challenges that we face when we're trying to read nonfiction. Remember, we talked about the headings could be deceiving, how it could go off on a detour, how it could give us overload of numbers. There are other hard things about it. And although it would be tempting to just skip it and try to find the same information in something a little easier to read, we actually grow more as a reader if we challenge ourselves to tackle it, to work our way through it. Okay, so I wanted to show you a diagram that is in our book that we're using for this unit, one of the books that we're using, on the weather. It comes from, let me move this over. It comes from Everything Weather. Everything Weather. And in this book, they have a diagram. Oops, going the wrong way. Okay, I think I've got it back all the way. They've got a diagram in here that goes for 2 pages. All right, and it's called a photographic diagram of the water cycle. Now, it could be very intimidating to try to read, but we want to remember our strategies that we've learned in previous lessons. As we're reading, we stop to ask ourselves, Joseph, what am I learning about here? What does this mean? What are they trying to tell me? Okay, so I'm going to zoom in because sometimes you don't even really know where to begin reading, but this one does have a little bit of a difference in some of the ways that the information is organized, and it certainly seems to me that that this right here is where we should begin. It's right underneath the title. It's kind of to the top and to the left, which is kind of the way we start when we read. We start at the top and to the left, and we read across to the right. Okay, it says scientists think that the water we drink, bathe in, and use to grow crops today has been here on Earth since long before the time of the dinosaurs. It has just been moving around and around in the atmosphere in a nearly endless cycle. Earth has a limited supply of water. It's a good thing, then, that Mother Nature created the water cycle, Earth's original recycling project. Here's how it works. Okay, so you might not know what the word cycle means. It's used again down here, recycling. But you go up here and you can see where it says a nearly endless cycle. And if we look at the word endless, we see that the suffix less means without. So this word endless means without end. A cycle without end. That is always recycling around. Can I have everybody look up here for me, please? I understand that in virtual school, you kind of get used to just listening to the teacher and not watching, but now you're here, and now you should be paying attention up here. That's how I know you're getting it. Okay, so I get the idea. Remember what we do. We stop. What are we learning here? Who can tell me? What are we learning in this section of the book? What are we learning? If you need to, you can reread it. Scientists think that the water we drink, bathe in, and use to grow crops today has been here on Earth since long before the time of the dinosaurs. It has just been moving around and around in the atmosphere in a nearly endless cycle. Earth has a limited supply of water. It's a good thing, then, that Mother Nature created the water cycle, Earth's original recycling project. Here's how it works. So what are we learning here? What are we learning? Anna? Say it again. What specifically are we learning about water? Because we are learning about water, but in this paragraph, what are we learning about water? Chen? Okay, you just repeated what's up there, but tell me, without repeating those words, can you put it in your own words? What are you learning about? Okay, I don't know if you would say that would be the most important thing that you're learning in that paragraph when it comes to dinosaurs, or that it's been here since the time of dinosaurs. Emma? Well, are we really learning about how the water cycle works here? Aliana?
You're learning about the water moving around the atmosphere.
Okay, and I can see what you're doing, but let me just talk to you for 1 second here about something that I've noticed. A lot of you repeat the exact words that are in the text without kind of going through that process of turning it into your own words. Okay? And if you don't start practicing that, turning it into your own words, it's going to be very hard for you when you start to write in your essays and you have to use your own words rather than copy or plagiarize from somebody else. Okay? You certainly can cite some text, but you need to put things in your own words. That's actually part of a good comprehension strategy. Bryn, you want to try it?
Yes. and recycling for the before dinosaurs were here.
Okay, that's a little bit better, but we have to be careful. We're learning that water moves through a cycle. That's basically what we're learning here. Water moves through a cycle. Right? It replenishes itself. It moves through a cycle. We don't know what that cycle is yet. We're probably going to learn about that cycle, right? And so we want to make sure that we're thinking about stopping and thinking, what am I learning here? Remember, we were trying to practice that the other day when we were taking notes. Stop and think, what are we really learning here? We're really learning that water moves through a cycle to replenish itself. We haven't run out of water yet, even though we use it every day, because it moves through a cycle. Okay? And I can anticipate as a reader that as I continue to read on these 2 pages with this big diagram, that I'm going to learn about that cycle. Okay, so in your journal, without using their words, if you remember what I said, you're going to write down what you just learned about water. So write it right in your journal. Remember what I said. Lila? Here you go. Water moves through a cycle to replenish itself. Lila, why don't you go ahead and roll the dice and choose something from a pocket that's not been taken yet. Nice listening. And remembering, water moves through a cycle to replenish itself. Now notice that the only things I used from the text that are in what I just learned was cycle, which is a scientific vocabulary I need to have in there, and water, which is the topic. Okay? So this is not easy to do, and you need to practice this type of thinking, this putting it into your own words. If you don't practice it, you won't get better at it. Okay, so let's move. Let me write mine down. Whoever is clicking a pen needs to stop, please. Okay, the next challenge that's posed by this diagram is that I don't know where to begin. I don't know where to begin reading because it's splashed over the whole page, a whole 2 pages. So I'm just going to choose a spot to read, and once I start reading, if I realize that I'm reading out of order, then I can just go back and reread and try to put it into order. But I'm thinking in my mind before I start that if this is a cycle, endless cycle, right? It has no end. I imagine that it's something that is continuous and that it doesn't matter where I start because it's not going to end in the same place it starts. All right, so I'm going to jump down right here. see if I can bring this in a little bit more. Rising up. Some of the water and spray from this moving waterfall will evaporate into the air in other bodies of water. Nope, I read that wrong. Let me go back. It surprised me because it's talking about a waterfall. And I'm wondering if I need to go back over here. Oh, it's just referring to the picture because I just went back and reread the box before it. It's referring to the picture of the waterfall that's behind this text box. Rising up. Some of the water and spray from this moving waterfall will evaporate into the air. I'm going to assume that the word evaporate is bolded because it's an important vocabulary word in this text. And just like the word cycle, I'm going to have to make sure that I use that vocabulary when I'm taking my notes because it's important. In other bodies of water, heat from the sun causes some water to evaporate or turn into water vapor or gas. In my mind, I'm picturing the playground. When we've gone out there, or we've looked out there and it's rained and there's all huge puddles, but then by the time we go out for recess, the puddles are gone. So I'm thinking the heat from the sun is evaporating that water. And what does evaporation mean? The sun causes some water to evaporate, or turn into water vapor or gas. So we know that we have that comma after the word evaporate with the or. It's telling us exactly what evaporate means. What does evaporate mean, Natalie? Right, so that the heat of the sun, or heat itself, causes it to turn into a vapor or a gas. This water vapor rises from the stream, river, or lake and goes into the air. Okay, I don't think I've ever seen water vapor, but that doesn't mean anything because vapor or gas is something that is invisible. But that this process is going on where the heat from the sun causes some of the water to turn into a vapor, and it's called rising up. So I'm thinking that vapor moves up, okay? Moves up. So when I get to the end of this, now I'm going to ask myself that same question. What am I learning about in this part? So what am I learning? What did we just learn? Zegan, what did you just learn when I read that part?
That maybe he evaporates water.
Maybe? Do you think there's a question about it? Okay, so what are we learning about? I love the fact we see all these hands up. What did we learn when we read this section, Sean?
He evaporates water like puddles and the top of the pond and stuff.
Okay, so heat causes evaporation.
And then it goes into the air.
What goes into the air?
Gas and vapor.
What kind of vapor is it? Water vapor, right? You want to be specific. You don't want it to be wishy-washy. Can you say that in another way, Chen?
Evaporation.
What about evaporation? What did you learn? Okay. So we don't know if it goes into a cloud, right? Okay, so from reading this text box, we don't know that it goes into a cloud. Okay, so we want to stay right in this text box. All right, one more, Aiden. Okay, I think we're getting a little bit better at saying it in our own words. I apologize for that. You didn't see me, but I pointed to him. And that's okay. It's perfectly fine. All right, so I think we're getting a little bit better at kind of putting it into our own words and focusing just on what we learned. Okay? That the surfaces of bodies of water, when heat from the sun can cause the water at the surface of those bodies of water to evaporate or turn into a gas. All right, so let's go ahead and jot what we learned into our journal. Doesn't matter because you're putting it down in your own words. I'm writing my own words and you can write your own words. Okay, so now I'm going to continue. Now I'm going to move over here because the arrow is showing me where to go. Chilling out. As water vapor cools in the air, it condenses. Okay, that bolded word, I know I'm going to need to use it when I get to the end of this and say, what did I learn in this part? What is this part teaching me? This means that it changes back into liquid form. You will notice the same kind of thing happening if you pour a cold glass of water on a hot day. Water forms on the outside of the glass. The water vapor in the warm air touches the cold glass and turns to liquid. Okay, so what are we learning in this section? What are we learning about in this section? Reread it if you have to. Remember, we want to think about what we learned and we want to put it in our own words. If you have an idea, go ahead and write it down. Elizabeth, you had a pencil in writer's workshop. It's a little bit distressing to me that we've gotten this far in reader's workshop and you haven't been able to write anything down because you can't find your pencil. Why don't you try to retrace your steps And remember what you did with your papers, your zoo papers, because you had a pencil then. Look on the floor around your desk. You don't have a community set of pencils, so you're going to have to figure it out. So what are we learning about here? Ren? Okay, I'm a little bit confused. Let me read it. Let's reread it, okay? Chilling out. As water vapor cools in the air, okay, because, all right, I'm thinking about what I know from science, and especially like when I was younger and it was really hot in the city, we would drive to the mountains because it was cooler. Mountains are higher and the air is cooler. So if I use that, what I already know about that, and I think about this rising vapor going up, and now it says, as water vapor cools in the air, it condenses. And then look at right after that. This means, it's telling me exactly what condenses mean. Natalie, could you put your eyes up here for me, please? Thank you. This means that it changes back into liquid form. Okay, so the cool air, right? The rising vapor becomes cooler, right? Because the air is cooler. And it starts to change back into a liquid form. Okay? And now they're going to give us an example of that. An example that we can all relate to. How many of you have had a cold glass of water and it gets all wet on the outside? All right? Might leave a ring on your table. All right? A lot of us buy these Tervis mugs because they're insulated, and they don't do that. Okay? So you know what I'm talking about. When I take my water bottle out of the refrigerator and I put it on my desk, I come back a few minutes later and there's water on the outside of it. The water inside is cold. The water vapor in the air gets cooled and it turns into liquid form. It's the water vapor in the air that is forming outside of your glass or your water bottle. All right, so the author is giving us an example that we can all relate to help us understand this very complex process of condensing. Condensation, condensing. The water vapor in the warm air touches the cold glass and turns it into a liquid. So what did we learn about in this text box? What was the important vocabulary that you can put into a sentence about what we learned about? Okay, let's try to mirror the idea here that this is a cycle. Okay? So let's think about it's the next step. Okay? So as the vapor cools, right? As the water vapor cools, what happens? Say it again. Well, not water on the outside. That was just an example. So what happens? What is condensation? What is condensation?
Condensation is whenever it goes up into the air, it cools, and then it turns back into liquid, and then.
Okay, and we can stop actually right there, right? When water vapor cools, it turns back into a liquid form, and this is called what? What is it called? What is it called? Okay, you got it?
Condensing.
Okay, can't change it. It's called condensation, okay? It condenses, that's the verb. The noun form of that is condensation, okay? So let's go ahead and write in our journal. So let's just review the process. I'm going to show you the rest of the boxes, and I'm going to have you independently jot down what you learned. But let's just talk about the process. When we encounter any text, really, but especially when it's difficult, we want to start reading. We don't want to just skip it. We want to start reading. And as we read, we stop and ask ourselves, what is this part teaching me? What am I learning? And then we take notes in our own words. We don't copy the words of the text. If we're just copying words from the text, we're doing the work of a machine. A machine can do that, right? But if we think about those words and turn them into our own words, now we're using our brain. We're processing information. That's how we get better at reading. So far we've learned that water moves through a cycle to replenish itself. Heat from the sun causes the surfaces of the water to become a gas. This water vapor rises. Rising water cools. Rising water, see, it's always good to reread your work. Rising water vapor cools, causing condensation. The water vapor turns back to a liquid. So remember that you want to make sure that you are stopping, asking yourself what you're learning, jotting down in your own words, in your journal what you're learning about, and then making your way through those hard parts by writing about what you're learning. Okay, I'm going to go ahead and show you the next box. I'll read it out loud. And then you can jot in your journal. Falling down. So we have rising up, chilling out, falling down. After so much water has condensed that the air can't hold it anymore, it falls as precipitation, rain, hail, sleet, or snow, into Earth's oceans, lakes, and rivers. Okay. You're going to ask yourself, what am I learning in this part? I am going to go ahead and turn off the camera, the recording, as we move into this independent work time.